Okay, today we're going to talk about similar figures. And that is when two figures have the exact same shape, but just not necessarily the same size. So for example, I'm sure you've done it before where you've had like a piece of clip art or something and you pull it from the corner and it enlarges it. That is a similar figure. We didn't change the shape of anything, we just enlarged it, essentially using a proportion. So let's look down here. It says, in the similar triangles below, corresponding angles have the same measure. Since 40 over 50, let me explain corresponding angles really quick. So corresponding angles are, if you were to put like the baby triangle next to the mama triangle, okay, that's like the simplest way I can explain it. You have to have their parts kind of matching up. So like the top of the small triangle and the top of the large triangle would be corresponding. Okay, and they have the exact same angle, if it's an angle measure. And then the corresponding sides are going to be proportional. So corresponding sides would be like, oh, well, this is the bottom of the small one. That corresponds to the bottom of the larger triangle. So let's look down here real quick. So it says a polygon is a closed plane figure formed by 3 or more line segments that don't cross. Two polygons are similar polygons if 1, the corresponding angles have the same measure, and 2, the lengths of the corresponding sides form equal ratios. Okay, so it's telling you right here the triangle ATC. So triangle ATC is similar to triangle OGD. So it says find the following values. And then it asks you to find x and y. Okay, so let's look at x first. X is this side right here. So the way that I like to set these up is I will say, okay, well, x corresponds to what part over here? 50. So x matches up with 50. And then in the denominator, we need to know a piece on the small triangle that matches up or is corresponding to a piece on the large triangle. So I could say, well, 24 matches up with y, but that's not going to allow me to solve anything because I'll have two variables. So I can say, well, x matches up with 50, and then 32 corresponds to the side length, that's 40. Okay, so I said the side, the left side, over the right side of the small triangle equals the left side over the right side of the larger triangle. And so now I'm going to find x using the strategies that we've learned this week. So I'm going to go ahead, I wrote this a little bit big, and say x over 32 equals 5 over 4. I just simplified 50 over 40 to 5 over 4. And now when I look at this one, I can tell that, okay, well, 4 times 8 is 32, and 5 times 8 is x. So x, hello, I said 5 times 8 is x. 5 times 8 would be 40. So this would have to equal 40. And so for y, let's do the same process, okay, except I'm trying to find y right here. So I could say, okay, well, I know I'm looking for y, and that matches up with 24. So now coming back over here, I can say, oh, well, 50 matches up with 40 because I just found 40. So what I did is I said the bottom over the left side equals the bottom over the left side. And now I'm going to simplify 24 over 40. So y over 50 is going to equal, I can divide these both by 8, 3 over 5. And now 5 times 10 is 50, and 3 times 10 would make y equal 30. Let's look at your next page, which talks about indirect measurement. It says you can use indirect measurement to measure distances that are difficult to measure directly. You can do this using proportions and then similar triangles. So it says a 6-foot person standing near a flagpole has a shadow 4.5 feet long. The flagpole has a shadow 15 feet long. What is the height of the flagpole? Okay, so we have this flagpole, and the flagpole has a shadow. Okay, and then we have a person, and the person has a shadow. So it says the person is 6 feet tall, and it has a shadow that's 4.5 feet long. And then here's our flagpole. I'm just gonna make it into a triangle. Okay, the flagpole has a shadow that's 15 feet long, and it's asking us to find the height of the flagpole. So I can set up my proportion. I'm gonna say the height of the flagpole over the shadow of the flagpole is gonna equal the height of the person over the shadow of the person. And so now I'm gonna go ahead and use cross products. 15 times 6 is 90. 4.5 times x is 4.5x. So 4.5 times my number is equal to 90. I'm going to divide both sides by 4.5, and I end up with x equals 20. So I figured out that my flagpole would be 20 feet tall. And if you look at it, it makes sense, right? Just kind of logically, 4.5 and 6. 6 is about a quarter longer. 15 and 20. 20 is about a quarter taller. So let's look at the next one. It says a 6-foot person has a shadow 5 feet long. A nearby tree has a shadow 30 feet long. What is the height of the tree? So we have a tree, right? And the tree shadow is 30 feet long. And then we have a person who has a shadow 5 feet long. So if we're going to set up the proportion, I'm going to say the height of the tree over the shadow of the tree equals the height of the person over the shadow of the person. So you'll notice that I did height over shadow equals height over shadow. That's kind of the most important part, that we're keeping that set up the same. So now 5 times 6 is 30, and 6 times 6 would be 36. So my tree would be 36 feet tall. And this last one. A telephone pole has a 12-foot shadow. A nearby person is 5 feet tall and has a 3-foot shadow. So here's our telephone pole. That's what's missing. It has a 12-foot shadow. Nearby, there's someone who's 5 feet tall. They have a 3-foot shadow. So let's go ahead and set this proportion up. I'm going to say the telephone pole's height over the shadow equals the person's height over their shadow. So we can tell that the shadow of the telephone pole is 4 times the shadow of the person. So that means that the pole must be 4 times the height of the person, which means our pole would be 20 feet tall.